All right, guys, we're starting things off here on chapter 14.2. 14.2 today, we're talking about estimating a population. Your calculator is going to be your best friend today because you're going to need it. You're either going to have to set up a proportional situation or change to constant. Proportionality is going to be in play today. Percentages are going to be in play today potentially. If we take a look at what we're talking about, we're going to be estimating a population. And so we're going to go straight to 14.2. And on 14.2, we're going to take a look at an example right here with robots and humans looking ahead down in the future.
What the? Oh no. I think I overslept.
All right, so if you take a look at what we got going on here, it says we've got a representative sample here, basically. Let me see if I can shrink that a little bit for you guys so you can see what's going on. So 200 years in the future, population consisting of humans and robots. First thing I'd pay attention to, this is a representative sample, which means it's proportional to the overall population that we're going to be talking about. And if you take a look here, you can see that we have about 2 out of 10, it appears, are robots. 2 out of 10 are robots. Now, what that 2 out of 10 could be is that could basically represent your constant proportion, constant proportionality that we've talked about before. So we could take that COP, that 2/10, and we could simply multiply that by my 13,500 that represents the entire population. You can pick that number up from down here. If you take 2/10 times 13,500, what are you going to get? You're going to get 2,700 robots. Okay, that's one technique that you could use. You could set up a proportion. That proportion could be robots over total in my representative sample equal to robots, which we don't know, that's the unknown, over total in my entire population. When we do that, we'd end up with 10x equal to 27,000. And we would divide both sides then by 10. And in each of those in that situation, we'd also get 2,700 as our answer. One other thing that you could consider is you could consider saying, hey, 2 over 10 is really the same thing as saying 20%. And 20% you could think of as 20% over or times 13,500, because if you recall, the word of in my class means multiply. And once again, if you took 20% or 0.2 multiplied by 13,500, you could get 2,700 robots. So I've given you in writing there 3 examples of how you could attack these types of problems. Okay. It looks like down the road that potentially what they're going to be using is the idea of that COP, or that constant of proportionality. So I'd be a little bit aware of that technique. All right. In this particular situation, we have a representative sample of 24 7th graders. And this is going to be in my, so first things that we need to identify, representative sample. We have 24 7th graders, and there are 3 students with April birthdays. So out of the 24 students in my sample, 3 of them have April birthdays. So we could set up our COP then as 3 over 24. Now, if you're quick about this and you can, identify it, certainly feel free to look at that and say, wait a second, 3 over 24 can simplify to 1/8. And in either of these 2 situations, we could say that those are the COPs, right? We have 448 total students in the 7th grade. 448 total students in the 7th grade. And so if I simply said, hey, I'm going to take my COP and I'm going to multiply my COP by 448, the result should be my answer. So when I take 1/8 times 448, I get 56. Obviously, this is multiple choice as you take a look. And in fact, 56 is one of the possible answers in that situation. And it's my belief that that is the correct answer. And in fact, it is. So again, this is using the COP. You could have set up a proportion. 1/8 equals x over 448. You could have gone back to the original fraction or the original ratio. 3 over 24 equals x over 4/48. This one might have been a little tougher with the percent just because it's not widely recognized, but if you look here carefully, 3 over 24, 1 over 8 is actually 12.5%. If you wanted to go that direction, you could multiply 12.5% times 4/48. So there's, like I said, 4 scenarios, and I'm giving you 4 techniques that you could use in order to solve this particular problem. All right, let's move ahead to my next piece of the puzzle, and we're looking at slide 3. How do you know that there is a COP, or a constant proportionality, between a representative sample and the population? The traits in that sample are proportional to the traits in the population. So when they say, and the key word really is this idea of a representative sample. If they're telling you it's a representative sample, they're in essence telling you we got a proportion to the overall population. All right, so that's important, finding that word. All right, let's move on to part deuce, see what we're looking at there. All right, these first 2 slides I'm not big fans of, so I'm actually going to skip through those, okay? And then we're going to go to this one. You want to find the number of fiction books in your local library. Couple key things that we're looking at. In the library, there are actually 5,000 books. They're going to give you 3 samples, sample A, sample B, sample C. We'll change color so you can identify those a little easier. The actual number of fiction books in the library happens to be 1,500. Which samples best represent the population? So what we're saying here is that really 1,500 of the 5,000 books in the library are actually fiction. All right, and again, there's multiple ways that you could do this, but they want us, I think, here to take the 3 samples and say, hey, using the 3 examples, using the COPs from these 3 samples, how can I get closest to this 1,500? All right, so here we go. I'm going to use green for sample A. Green for sample A. Identify it like so. And in this situation, you can see we've got 1 fiction book, 2 fiction books out of 1, 2, 3, 4, 5, 6, 7. So our COP here is going to be 2 out of 7. Right? 2 out of 7, and this represents our COP. So if I took 2 over 7 and I multiplied it by my 5,000 total books, this is going to yield 2 ABC7 times 5,000, about 1,429 books. All right. So the question becomes, can I get any closer to 1,500 than 1,429? Let's switch over to blue. So I'm going to use sample B is going to be my blue. The COP here is going to be what? 12 out of my total. So it looks like I've got 12 and 15 is 27, 27 and 12 is 39. So it looks like I'm at 12 over 39 is going to be my COP. 12 over 39 is my COP. Once again, I'm going to multiply that by 5,000 total books. And if I took 12 divided by 39, now again, some of you guys might realize, hey, 12 over 39 could actually simplify. You are welcome to do that. I don't know. I think in some cases that might be more of a hassle than if you just left it alone. Looks like I'm coming up with about 1,538 books on that one. 1,538 books. And we'll switch over to black, is another color I've got here. And I'll go, that's going to be sample C. So I've got 40 fiction books. And I think if you add all those numbers up, 69, 76, 76 and what, 58, I believe should come to 134. So it looks like 40 out of my 134 books in this sample are fiction books. So my COP for letter C is 40L134. Once again, I think you come to the realization that we could simplify that if you wanted to. And even once I punch in 40 ABC 134 and hit my multiplication sign, it simplifies it for me. So you could think about doing it that way. I'm going to multiply it by that 5,000, by the total. And this is going to yield what? 1,493 books. So it appears as though, in which case do I come up with closest to 1,500? It appears as though my answer should be letter C. Let's see what we got here. And if you look real carefully, and it's hard for you guys to probably see this, boom, letter C is in fact the correct answer. Okay? All right, let's move on then to slide number 4. And on slide number 4, what do we got going on here? How is the estimated population affected by the size of the sample? Well, again, if your size of your sample is small, then you're just giving yourself more opportunity to be not precise, or there's not really enough information to have a strong estimation. And again, the larger then that your sample is, one would typically think the more accurate you're going to be. All right? Okay. That's, again, in our society right now, one of the things that they're trying to get people to do is to vote. So we think the more people we have to vote, then the more accurate the sample size is of what the people of that particular state actually feel. Sorry, Mr. May, if I'm stealing your
You've
thunder.
got mail. You've got whale.
Something fishy is going on here.
All right, so before we move on to this particular problem, let's go ahead and break for our commercial today. If you take a look at our commercial today, here is the code word for today. Okay, code word for today, Wile E. Coyote. You got to make sure you spell that right. Okay, so write that down in the comments section of your actual homework assignment that you send to me via Pearson. So in this particular situation, I got a computer factory that has 670 computers in storage. 3 inspectors each check 50 of the computers in different areas of the storage room and note the number of defective computers they find. Each inspector used his or her results to estimate the total number of defective computers. Okay? So it looks as if we say, hey, this person has 4 out of 50. This person is 1 out of 50. Maybe change colors here with you. So B is 1 out of 50. And C is 2 out of 50. All right, so C is 2 out of 50. And so we're going to use those numbers then. Those would represent, I would think, the COPs. And so we're going to go ahead and use that number, and we're going to use the number 670 to see how many of them actually, what their estimate is. All right, so if I take 2/50ths and I multiply it by 670, 2 ABC 50 times 670, I get, what? It's about 27-ish. Okay, about 27 defective computers. If I say 4 out of 50, and I take 4 ABC 50, and I multiply that by 670, this person, which would be person A, red, is saying that there's going to be about, what, 53 and a half, 54 defective computers. And again, that should make sense that it's 4/50ths is twice as big as 2/50ths, so if you double 27, you should have been able to get that answer. And then 1/50th, technically, we should be able to about cut 27 and a half. And if I do so, I'm probably going to be hovering around 13 or 14. If I took 1/50th and I multiplied 1/50th then times 1/50th times 670, one ABC 50 times 670 times 13 2/5. We'll call that approximately 13. So you just have a weighty, like lasagna looking thing. It's going to be about 13 computers. So that's basically what each of their estimates were. Take a look at question B. Suppose the actual number of defective computers in the storage is 29. Which inspector's estimate is the best? Obviously, that would mean that you would think this dude right here has the best estimate. Okay, so we're saying it's Inspector C, right? So they do very similar stuff to what I did, and you can see that they said C's is the best right here because they come up to about 27. So they had the same numbers that I did, same techniques that I did. So using that COP is going to be an effective tool, and obviously that's what we're leaning on right now anyways. Take a look at the second one, a very similar kind of question. This will be the last question we're taking a look at. Apple orchard, 874 trees, 3 gardeners checking 75 trees. So once again, I'm going to go ahead and set up, hey, I've got 11 over 75 for garden A. I've got garden B is at 18 over 75. If I'm reading this correctly, I'm kind of not reading everything, so I'm just playing 7th grade kid here. And then 13 over 75 for C. Okay? Each gardener using his or her results to estimate the total number of trees in the orchard that are ready for picking. So let's play off of person C, and there are 874 apple trees. So if I took this 13/75 and I multiplied it by 874 and I rounded it off to the nearest whole number, I believe my number that I come up with is approximately about 151 trees. Okay, about 151 trees. Again, approximately, use the curly Q equal sign. 11 divide ABC 75, 11 ABC 75, so I'm up to A now, and I'm going to multiply that by 870. And so when I do that, I'm at about 128 trees. And last but not least, I'm over here at 18/75. I'm multiplying that by 874. 18 ABC 75 times 874, and I'm at about 210 trees. Okay. Which gardeners? What was each gardener's estimates? Okay. And suppose the actual number of trees ready for picking is 161. Which one's got the best guess? It looks like, again, it might be person C, based upon the idea that 151 is closest to 161. So, see if we did that correctly. And you can see they came up with the same numbers I did, 128, approximately 210, 151, and once again, we're looking at, let's see, what are we doing? I must have missed a step here. So there's those numbers right there. How can you use the information? Larger sample tends to get better estimates. So if we combine those, we could find the COP. How close are we going to be if we combine those? Okay. How can you use the information best? So if we took all of that and we said, hey, we've got, I'm going to black here, a total of 75 plus 75 plus 75, I believe that's 225 trees. And we have 18, we have 11, it's 29, 29 and 13 is 42, 42 divided by 225. So if I took 42 25ths and I multiplied that by my 874 trees, again, why are we doing this? We're getting a better estimate by combining these three people's estimates and therefore having a larger sample to choose from. So 42 ABC 225 times 874, and I get about 163 trees here. So what they're saying here is probably our best guess, our best estimate from an individual standpoint would have been Gardner C. But if we wanted even to get more accurate than that, if we combined Gardner A, Gardner B, and Gardner C into one and said, hey, we're going to combine these samples, we're going to get around 163, which we're saying because it's a larger group, larger sample, we should have a better shot or a better answer. All right, guys. Hey, have a good one. Thanks. I know this one went a little bit long. I apologize. I'll talk to you later. Have a great day.